Okay, start.
Yes, sir. Welcome everyone to the presentation on modern manufacturing process. My presentation topic includes robots in manufacturing or how robots are related to manufacturing. I will go through these outlines while presenting the whole slide. I will discuss some brief history of robots. Then I will make an introduction to robots and robotics. As the topic is mainly based on the relationship of robotics with manufacturing, that's why I have focused on robotics and manufacturing and the areas of manufacturing where robots are used. I have discussed briefly. Then I will show some market statistics on the progressive advancement of robots. Uh, After that, we will discuss the components included in a robot and different types of robots that are used vastly in practice. Lastly, the presentation summarizes about the robotics automation or robotic automation, which is considered as the future of modern manufacturing. History of robot. Firstly, the word robot. The word robot comes from the word robota, which is a word used by the people of Czech Republic. This robota word means tireless work or something that can work tirelessly. The first robot was designed by George Devil in 1954. He also establishes the first robot company named Unimation in 1962. That's why he is considered as the father of robotics. His first automation was employed in the manufacture of TV picture tubes. Unimate is termed as the first generation robots. Later on 19 later on 1980, the robot industry enters a phase of rapid growth. Uh, Many industry and industrialized are introducing programs and courses in robotics, and thus the advancement occurs in the field. And in addition of sensing device and path control capabilities are introduced by this time. These type of robots are termed as the second generation robot. And the in previous slide we have shown the automatic manufacture of TV picture tubes. This was the first invention, and this is termed as the first generation robot. And this type of robots with the addition of sensing device and path control capabilities are termed as the second generation robots. uh, Here comes the third generation robots, which are capable of working in mobility areas. By this time, NASA sends its rover launch towards Mars in quest of water in Mars. Here we can see some pictures or figures of such type of robots. These robots are termed as the third generation robots. So far, we have discussed about the history of robot. Now we will go for the term robot. What does the term robot mean? According to the Robotic Institute of America, a robot is defined as a robot is a programmable, multifunctional manipulator designed to move material, parts, tools, or special devices through the variable programmed motion for the performance of a variety of tasks. Uh, the thing that is programmable and performed multifunctional capabilities of moving materials, parts, and special device in accordance to the prescribed program is termed as robot in short. And the branch of technology that deals with the design, construction, and operation and application of robots is termed as the robotics. Here we can see three different types of robots uh, that are doing different jobs. The first one is doing office work, and the second one is trying to grip something, and the third one is involved in packaging boxes or some material. Now we will go for robotics and manufacturing, or the relation of robotics to manufacturing. Robotics and manufacturing are termed as the natural partnership. In case of maximum efficiency, safety, and competitive advantage, there is no other alternative to go for automated solutions, I think. In case of repetitive tasks, it is very much encouraging to be focused on the speed, accuracy, durability of the robots. In such cases, robotic automation can play a vital role, I think. And then the automated robots are working efficiently the jobs which are intricate or complex for human beings, or to enter human beings to perform the jobs such as lifting, holding heavy materials. In addition to this, robotic automation also allows the companies to compete with the global markets. Besides, this implementation also increases productivity, worker safety, satisfaction, and a better bottom line, or a flexible outcome. Now I will show you some areas of manufacturing where robots are used. Uh, Robots are vastly used in aerospace industry nowadays, and automotive manufacturing and supply. From the very beginning, robots are used vastly in automotive manufacturing. Robots are now being used in agricultural harvester and picking up of vegetables or some other materials. uh, Also used in chemical, rubber, and plastic manufacturing industries. uh, Robots are used in electrical and electronic sector. Food stuff and beverage manufacturing industries are hugely used robots for food preservation unit, or to remove chemical from the food stuff and checking whether it is chemical free or not. In the glass, ceramic, and mineral production industries, robots are used. In 3D printing technology, furniture manufacturing for painting or some other text or assembly. In power plant, specifically nuclear power plant, healthcare, hospitals, patient care, surgery research. In these sectors, robots are used vastly. In addition to this, robots are largely being used in laboratories, military section, mining industries, and different types of transportation devices. And also robots are used for entertainment purpose in home or theater. Here I will show you some market statistics of robots. Uh, Here we can see the annual supply of robots in between 2013 to 2015 in United States. uh, Along the horizontal line, the it is shown the units consumed in that year, and along the vertical axis, the sector or the industry that are used robots has been shown. The blue color indicates consume the unit consumed in the year of 2013, and the ash color indicates the units consumed in the year of 2014, and the red color indicates the units consumed in 2015. In the case of automotive sector, or electrical device or electronics, there is a rapid growth in the consumption of robots from the year of 2013 to 2015. uh, but in case of motor vehicles industry, the consumption rate is as high is high was high in 2014, but the rate of consumption decreases in 2015. uh, but in chemical, rubber, and plastic industries, the new utilization of robots is going downward with the advancement of this year. Because of the stable nature of these robots in this arena. This above data has been collected from the International Federation of Robotics, shortly termed as IFR. In this slide, the utilization statistics of different developed countries has been shown from the year of 2008 to 2014. Uh, in the year of 2008, Japan utilizes a huge quantity of robots in their production. Sorry. In the year of 2008, Japan utilizes a huge quantity of robots in their production in comparison to the other countries shown here. Uh, in 2010, if we go for 2010, the Republic of Korea consumed robots at a higher rate in comparison to other countries. But in 2014, China has crossed Japan in the utilization of robots. This statistics is also collected from International Federation of Robotics, IFR. Lastly, in this slide, in market statistics of robots, I will show you the demand of robots in the factories of China with the advancement of year and other countries also. In comparison to the previous year, in the year of 2014, the utilization of robot increases about 56% in China and 17% in Japan, 11% in United States, 14% in Korea, and 10% in Germany. Uh, from this above discussion of market statistics, we can conclude that the robotic automation is the base of modern manufacturing. Uh, those are using in various industries for the increment of production rate. Here I have tried to show you the main component of robots, which include the arm or manipulator, sensors or sensing devices, indicators, actuator, and drive, and the controller system. These are the main components of a robot. The in the picture or figure attached here, we can show different parts in the robots shown here. We will briefly discuss about the each term or each parts. Firstly, the arm or manipulator. Uh, it is uh, termed as the main structural element of a robot. The degrees of freedom depends on the arm. Uh, Degrees of freedom means how many direction the robot can move or its arm can move. That's why the work volume is mostly dependent on the functionality of the arm. A simple Here we can see a robot shown its arm. uh, this is termed as the lower arm, and this is termed as the upper arm. In case of several arms attached here, these are attached as links, and uh, 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 in some cases the links are also termed as arm or manipulator, which also allows a robot to move in any kind of direction. Here we can see a simple robot with the degrees of freedom in three ways: up and down, left and right, and forward and backward. According to the degrees of freedom or the moving capability, the robots are also classified in different ways. Here we will see this type of terms in later. Now we will go for sensing devices. Uh, Sensing devices. Sensors or sensing devices. Sensor means which creates mainly senses in robots. It gives the feedback about the surrounding and on which environment the robot is working, and it also collects information and sends it to the robot control robot controller, and it also protects robot from bumping to another robots, and it also assists different parts and in parts to or indefectors to work according to the sense it achieved from the surrounding. Here we can see some of the sensors shown here. The first one is touch sensor, second one is ultrasonic sensor which operates on the sound come from the environment, third one is the color sensor, fourth one is the sound sensor, and fifth one is the light sensor, and last one is the motor sensor. In addition to this, there are various types of sensing device are also available. The third one is the indefector. This is the device attached to robot or wrist or arm to perform a specific task, or the part in a robot that perform the specific task is termed as the indefector, or it is termed as the end part. Here we can see in the figure there is a welding torch and the gripper shown in figure. Some variations of an indefector are gripper, vacuum pump, magnets, or what kind of work I want to do with the robot is mainly depends on the indefector I have attached with the robot. And then we will go for drive system, which exactly supplies the power to drive the robot, and the joints are moved by actuators powered by a particular form of drive system. In robot, we will normally use three types of drive system. These are called hydraulic drives, electric drives, and pneumatic drive system. Drive system mainly determines the speed of the arm movement or manipulator movement, the strength of the robot, dynamic performance, and some kinds of applications. What kind of applications we will use in these robots? Uh, in hydraulic robots normally provide greater speed and strength. Electric system provides moderate speed, and pneumatic system are used for smaller robots. Here we can see some of the drive available. DC motor, which is electric drive system, and pneumatic drive system we have shown here, and a classic DC motor, industrial servo stepper motor. These are also electric drive system. Uh, what this drive system mainly do is uh, the instrument used in this drive system are termed as the next component actuators. Actuation is the process is mainly called as the conversion of energy to mechanical form. If we use electrical actuators, then the energy will this conversion of energy is occurs with the help of motor or gear, some kind of gear. And if we use pneumatic devices, then this type of conversion occurs through turbines, uh, or another kind of blades. But in kinds of hydraulic drives, this kind of conversion occurs through pumps. uh, Actuators are termed as the muscles of robots. There are many types of actuators available depending on the load involved. What kind of or what kind of work we will do through these robots. The term load is associated with many factors such as force, torque, speed of operation, accuracy, precision, and power consumption. These terms are mainly related with actuators in robot. And the last component, which is also called the brain of robot, or the programmed uh, prescribed in the section of robot, is called the controller. A controller is a device which takes one or more inputs and adjusts its output to so a connected device can functions in a controlled manner. To control the robot, the parts or components used in robot are termed as controller. This controller is termed as the brain of robot. It also network to other systems so that the robot may work together with other mechanisms, machines, process, or robots. Next, we will see some of the application of robots in different manufacturing sector. Firstly, robots in material handling section. Here we will show some figures. uh, these robots are performing jobs that are to picking up or transfer boxes, or picking up boxes to work in a uh, prescribed manner. This type of works are vastly used in manufacturing industries by robot. These are very common form of robot nowadays used in material handling section. Now we will see robots in agriculture section. In this figure we will in this three figure we will see how robots are used in agriculture. First one is picking up vegetables. Robot is picking up vegetables from field. And the second one is to distribute pesticides, and to also to monitor about the or taking pictures about the field. And the second one is to prepare the land for agriculture purpose. In this all sections robots are used in vastly. Robots in space. uh, in these two pictures we also say robots are used vastly in space, to carry out research on the Mars, about its land or availability of water, or to take pictures about the land quality. This type of robots are used nowadays. uh, Robots in medical sector. uh, Nowadays in medical sector, in operation theaters, robotic instruments are used fastly. And in different cases of taking of germs, robots are utilizing these hazardous taxes which are harmful for man, or different types of virus handling. This type of robots are used. Robots in hazardous environments. uh, 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 Robots are also used in the sector where man cannot enter or handle harmful chemicals. In such environments robots are used vastly to perform the tasks of human. uh, Mainly this type of robots are used in chemical industries, or industries that work with fire hazards, or it must ensure the safety of fire. In these cases these type of robots are used. Now we will see the different types of robots normally used in practice or available in market. Mobile robot. The robots are that are used in mobility areas such as space robots. This type of robots are termed as mobile robots. Uh, hmm, Second, we will see walking or leg robot. This type of robots are mainly modeled uh, uh, with the picture of some insects or crawfish. In this model, this type of walking or leg robots are used. These robots are usually brought in when the terrain is rocky and difficult to enter with wheels. When the terrain is rocky, it is difficult for men to move there and perform research. This in this sector, this type of walking or leg robots are used. Uh, Autonomous robot. This type of robots are self-supporting, or in other words self-contained. In other words they rely on their own brains. uh, ac- uh, the direction it achieves from its sensing device to controller, it operates self-supporting way. This type of robots are the fourth generation robots, mainly termed fourth generation robots. uh, Autonomous underwater robot. These type of boats are used in searching or conducting research of soil underwater, or finding nature of living being underwater. Uh, these are termed as autonomous underwater robot. Next, we'll go for Cartesian robot. Cartesian means it is mainly related to coordinate system. Uh, if the robot is moved in x, y, and z direction, this type of robots is termed as Cartesian robot. Then we will go for this type of Cartesian robot is highly rigid structure that allows it to lift heavy objects. Mainly for lifting heavy objects, this type of robots are used. Next, we will go for cylindrical robot. This type of robots, instead of doing Cartesian robot. It will, in addition of doing Cartesian coordinate, it will also rotate. This type of robots are termed as cylindrical robot. This type of robots are used in die casting system and spot welding system. SCARA robot. These robots are also these are termed as pick and place robot. These robots are has at least two rotary joints include in here, which also permits the robot to move in uh, several ways in comparison with the cylindrical robot we have shown before. Now we will see spherical robot. This type of robots are used in die casting, gas welding and arc welding system. These are the robots whose axis form a polar coordinate system. We can see this type of system in the figure shown in here. The rotation is several in case of Cartesian in comparison with the Cartesian robot and cylindrical robot. Articulated robot. This is a robot whose arm has at least three rotary joints, or many more. This type of robots are used in assembly operations. Unmanned aerial robot. This type of robots will introduce you the concepts of robot flight and movement simultaneously, and are used in military institute or security section for monitoring purpose. Next, we'll see washdown robots. This type of robots are used in food processing units to maintain the hygiene requirements. Then we will see palletizer robot. This type of robots are used to bundle and stock boxes into pallets for storage and shipment. Uh, Lastly, we will see Okubot, which is used to in pressing operations, measures the degree for advanced wear and resistance based on force, and occurs on the continuously presses its Oku form dummy into the same seats. Different types of foaming industries, or different types of sofa making industries, this type of robots are used for pressing purpose. These are all about different types of robots I have shown, and the last slide of my presentation will show the robotic automation, which is considered as the future of modern manufacturing, or why it is considered as the future of modern manufacturing. Robots used in manufacturing create efficiencies all the way from the raw materials handling to the finished product packaging. Uh, from the raw material handling to finished product, robots are used vastly in manufacturing sector. Robots can be programmed to operate 24 hours, 7 days in a week in lights out situations for continuous production. Uh, Robots, if we use human being cannot capable of doing such tireless work for 24 hours, 7 days in a week. In this section, robots are used vastly. Robotic equipment is highly flexible and can be customized to perform even complex function, which is quite impossible, such as hazardous environments or fire hazards section. Human beings are not capable of doing work there comfortably. With robotics in greater use today than ever, manufacturers increasingly need to embrace automation to stay competitive, and are leveraging robotic automation for a wider number of applications. Uh, Manufacturers are increasingly use robotic automation to compete with the global market. I have already shown this in the market statistics in my slides. Automation can be highly cost effective for nearly every size of company, including small shops. Uh, Robotic automation has found its way in many different sections of manufacturing. They are doing works of assembly, welding, shipping, transferring, handling raw materials, and also the finished product packaging. Instead of this, robots also save money and time. They are also scalable according to our requirement. Robots are easy to program and create more jobs nowadays. Thank you all for your kind concentration.
Okay, thank you, Prantakarwa. That was a really long and continuous presentation. Do you have any question from audience?
Sir, just one thing to share.
Yes,
From Prantukar's presentation, what I understand that this is a high-end manufacturing process, very high-end,
yes.
fast. I mean, you cannot use it for kind of like garments, R&D sectors, like say normal process.
No, 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 no.
It's
That's
very
not.
high-end.
That's
And
not
another
right.
thing,
That's
the
not right.
initial cost of this robot manufacturing or robotic manufacturing process is supposed to be very costly, the capital cost. And
Manufacture cost will grow high, but the further cost or maintenance cost will grow lower, I think.
yes, that I understand that if it is a distributed cost, I mean, the cost is distributed. So automobile industry, they can afford robot. They don't take humans. They take robot because they can afford the distributed cost. Say, a company like Toyota, they produce some 5 million units every year. So they can afford a high-end robot, no problem. But in low-end industry, probably that is a problem. And another thing, due to from the statistics of the countries using robots, and gradually it is increasing, there is a trend. Most of the countries, they are the economy, first economy, second economy, third economy. First is USA, second is China, third is Japan, maybe fourth is Germany. All of them are like this. First economy of the world, second economy of the world, third and fourth. They are using robots. So there is also another consideration, affordability of those things. This is the, I mean, derivation of my own derivation from your presentation. I leave it for the house to think about it. Another thing,
Okay.
from that application of the robot, what I understand that where the job is, I mean, not fit for human, like hazardous job, risky job, repetitive job where mistake is supposed to be, like humans are prone to error. So you need someone who is not going to make error, like a fail-safe device, a robot. A robot is a device, a fail-safe device. Something like that, sir, what I understand, Dr. Arif, sir.
Yes, yes, yes. You are right. But I have a comment on your opinion. It's like the middle end or low end manufacturing companies, they are actually using automation nowadays quite a lot. I have visited a fan manufacturing industry, Superstar Group, maybe a couple of weeks ago, and I saw that they're using the die casting for manufacturing the fan, the base. Okay, and for manufacturing the die in the die casting machine, they are using a robot to spray the lubricant into the die because human cannot go in there. It is very risky
Sir.
for humans. So robots are being used. And also if I talk about the lower end companies, like in the same company, my friend was the manager in there, and he told me to do something like there is a process of separating um, fan blades according to their weight. Like they have a weight range between 310 to 340, the
Exactly.
340 gram. Okay, and all this they need to separate in different groups, because in a single fan you cannot use three blades with different,
Different words. You're right, sir. You're
because
very
it
right.
will create turbulence and it will be vibrating. So that's why they need to separate them according to the weight. And that is what doing a woman I saw was doing that. And there is quite often she makes error. Okay, and using a robot in there, or a automation system, it is actually a robot. Okay, using the automation robot, it will cost the company like at the beginning maybe more than 1 lakh taka. But if he takes that opportunity, there is a less of possibility of error. Okay, that will
Exactly.
also increase the production rate, as well as it will save money.
Eliminate the
And
error.
it will improve the quality. Okay, so
Sir.
there is always opportunity for low industries too, but it is not still widely used, because
For us, sir,
most of the industries, they actually don't know much about these things. They just know how to make money. you know.
So it is like, I mean, it's a blend. I mean, according to my requirement, I mean, existing condition, economic condition, say is a socio-economic condition. Because if you put robot there, people are getting jobless for if they are doing the job of people in a
Yes,
country like us.
that's 100% true for low or lower middle income countries. But in the case of high developed country like USA, Japan, or Australia, Canada, they prefer robot because they have a very huge labor cost. That's
Yes.
why they cannot the industries in those countries cannot survive.
You are very right, sir.
Yeah,
Very right, sir.
that is why they prefer robots. But in the country like ours, putting a robot instead of a human, it actually reduces the job opportunity. But in some cases you need to do that. uh,
Exactly,
for,
sir. Those are
for
not fit
example,
for human job.
yeah, for example, those places where human cannot go, it's hazardous to human, or you need much more accuracy. So you
Right.
also need to make the job available. At the same time, you need the quality, you know.
Yes, sir. Yes, sir.
Okay, any other question from audience?
Sir, I have a question.
Okay, go ahead, Russell.
In which basis there are several robot in this slide?
In which basis? You can ask that to Pranto Karua. Pranto Karua.
Hear the question properly. Can you repeat, please?
What is the basis to discretize the robots? Several types of robots.
If we vastly discuss robots, it's a huge chapter. That's why uh, uh, I didn't discretize anything. I take some common robots that are related to manufacturing industries.
No, Pranto, I think you did not understand his question. His question was, your topic is robots in manufacturing, but
Yes,
you
sir.
have discussed quite a lot about the classification components and something like that for robots, and there are some robots which are not related to manufacturing. So you have also included them. I think Russell has that concern. Am I right, Russell?
Yes, sir. I have another question about the program. There is no related slide or something that means the program is used in robots and the demerits of the robot.
Yeah, that's right.
I
Pranto?
have a slide to show the limitations of robot. I can also I can share this. But if we show program, that's a huge course to show. Simply one program cannot describe a robot,
Exactly.
robotic controlling system. I have included controller section in the
May
uh,
I add a little
in
bit,
my slide.
if you allow, please, sir?
Okay, go
So to
ahead.
say
There
that,
is another course
One
related
second,
to.
Pranto, hang on a second.
sir,
Okay.
what I understand that every robot, particularly manufacturing robots, say is a automotive industry. So they are using a particular type of robot which is programmed for doing that particular job. So his program is kind of unique. It will never match with another program or another robot which is shifting heavy loads. Those two are totally different. So
Yes, of
basing on
course.
that, you can write programs in any language that is suitable for that robot to perform. That is what I understand.
Yes, the robotics is like that. You design a robot
Customized.
for a specific task and you perform that task. And if you want to modify, then either you have to change the program or also you have to change the degree of freedom, movements, and sometimes arms manipulators. A lot of things need to be changed
A
for
lot
a
of things,
existing
sir.
robot
Even
to do
sensory also, sensory
different tasks.
systems, controllers, some cases you have to change the entire controller.
Yes, of course. The same robot cannot be used for all purpose.
Exactly, sir. There is no generic program or generic version.
Yeah,
Maybe there
in
can be
future it will come
modifications.
because of the artificial intelligence. In future, the robots will be able to perform a lot of tasks. Like, for example, the robots, human assistant robots, they can perform multiple tasks, like they can cook, they can serve people, like they can wash the dishes, they can tidy up
This
your
is
house.
already there in use. They call it humanoid robot. Humanoid robot.
Yes, there are multiple.
Japan
Yeah.
commercialize these things already.
Yes, yes.
Domestic for domestic purpose.
Yeah,
They
sometimes
can
they are
wash
also
your
being used in the restaurants.
Yes, sir. I
housekeeping.
have also goes through this humanoid robots, but I cannot use it because the slides is only based on manufacturing.
Yeah, yeah.
Yes, you're
Yeah,
very
Pranav,
right.
we're just discussing. It's not
Yes, sir.
about
Yes, sir.
your
Yes.
presentation, actually. To do make a general comment about your presentation, I think Russell was quite a bit right. There has been some distraction in your presentation, like there are some robots which are not related to the manufacturing, but overall it's a really interesting presentation because I think the audience might have a general idea about robots too. Uh, not only manufacturing, but we also need to know different types of robots so that we can think of using them in different manufacturing sector. You know,
Yes.
if you look at the Mars robot, they're using, what are they doing? They're collecting rocks, they're searching for water, and they're analyzing the various materials, and we have to think positively, and we have to think like, how can I use the same robotic system in a different purpose, like in a different industry for manufacturing. If you don't have any idea about what type of robots are available in the available, or what type of robots can be made, if you have the general idea about the kind of robots and kind of control system or the movement, then you can think of using them in your in the manufacturing sector. Okay,
Yes, sir. Thank you.
that's also beneficial. It's not like a demerit. Okay.
Yes, sir. Thank you, sir.
Okay, any
Assalamualaikum,
other
sir.
question from anyone?
Sir, Assalamualaikum, sir.
Go ahead, Rana.
Sir, would you allow me to add something if we have available
Sure,
time?
sure, we are having open discussion.
Sir, I was thinking about some misconception regarding automation, electromechanical system, and robotics. Actually, in industries, when we have to process the system, then we can use electromechanical system. Sometimes we confuse with the electromechanical system or purely mechatronic system with the robotics. So in case of manufacturing plant, we can use electromechanical system, and if the electromechanical system has a feedback system, then we can call it a mechatronic system, which has a control part. And in case the mechatronic system has a world to recognize and it can learn from the world, then we can declare it as a robot. So in case declaring some system or a automation as a robot, we must have the capacity to know the world for the system. So in case of every system which has automation, we cannot declare it as a robot.
No,
And
no,
in
no,
case of sir,
of
sir.
course not.
And robotics has a classification. A modern world has two classification. First of all is soft robotics, and second of all is physical robotics. Soft robotics deals with the artificial intelligence or process automation or something like that, and hard automation related to the manipulator or automotive automation or drones. That's kind of things. So when we are using PLC or sensor-based system, in case of industrial automation, we cannot call it as a robotics. We can call it a mechatronic system with a feedback system because it doesn't have a clear outlook of its world. If we can change the parameter, certain parameter of industrial production line, it cannot change the production line change. We must need to reprogram the control system. So suppose the system doesn't have the capacity to know its world, so we cannot call it as a robot, but we can call it as a mechatronic system which has a capacity to automate itself.
Okay,
As far as
in
I
that
know, sir.
case, Rana, in that case, in the automotive industry, the robots, we call them robots who actually they do the spot welding.
Sir,
If you look at there are several pictures available, or several things available. They actually do the spot welding in various in the
sir,
automobile
sir, sir.
body. So what happens in that case? Is that a robot
In
or?
that case, yes, Absolutely, there's a robot because it has a control volume to monitor at all the process system and time, because they use camera for verify its image processing. They verify the pixels from the image, and they verify the color density from the every perspective. For paintings, for welding, they just use the shape finding system. Same process, image processing. They just capture the image and find the edges to weld itself, and then the robot follow the images. Suppose you just position your system or the welded material at display position. The camera which is used for capturing the image will automatically detect the edge that it just displays itself, and then the weld will draw a trajectory line to weld itself. So it has a world control volume where you can redefine the coordinate system. So if I want to weld a car at a using a robotic system, then if I just displace the car to weld, then it can detect the displacement and correct it according to its function. So we can call it robotics. But in case of a production line, when are using a simple sensor for sorting, like in case of food industries in Bangladesh, food industries has to maintain some hygienic work field. In case of Walton, they are producing compressor. For compressor, it's very much important to use a clean room. So there should be no dust at all in case of a clean room. So they are using automation for maintaining their clean room. So they are using a production line which has an automation system. But if we just displace a compressor at its production line, it cannot detect the displacement.
That's not a robot,
Sir,
definitely.
sir, exactly, sir. That's what I want to say. When you are painting with a robotic arm, it has a certain control volume. It has a numerous parameter to sense itself whether the uh, uh, whether the component is positioned itself at a certain coordinate system. If you displace the system or the structure, it will certainly detect automatically and redefine its path, reprogram itself. So we are using a reprogrammable function in case of robotics. It has something self-learning system so that it can redefine its error and minimize it. We call it motion control system, PID, PD, something like control system is used in case of robotics.
I think, Rana, sometimes you are mixing with the artificial intelligence and the robotics.
No, sir. Actually, artificial intelligence is a different thing, but in case of robotics, they must have some motion control system.
Yep. They must have the motion control system. They must have a control volume to cover.
Exactly,
And
sir.
they must have a specific task, and you can modify that specific task according to the requirement. And sometimes we use artificial intelligence in those robots to add to change the program according to the requirement.
Sir.
Something
Yes,
like
sir. Yes, sir.
yeah. All right, there will be a lot of discussion if we
So
continue.
thank you, sir,
like
for
that.
giving the floor.
Yeah, it's all right. It was an open discussion, and thank you very much, Pranto Karua, for your presentation. It has raised a lot of concern between us, and I think that will lead us to learn more and study more about the robotics, and it will be really interesting to see that the people we are attending this lecture, they will think about these robots and how these robots can be employed in their manufacturing sector. They will think about that, I hope.
Thank you, sir. Thank you very much.
Thank you, sir.
All right. Okay. Next presentation will be from Tarin, right?
Yes, sir. Ready, sir.
Please start your presentation.
So thank you, sir. Is my presentation slide visible on screen?
Yes, yes. Tarin, I think, can you just change the background to white? Oh no, it's not, it's gonna be a problem. Don't change it to white. Continue. It's better to have the presentation, academic presentation specifically with a white background.
Okay, so next time I will do, sir. Good evening. I am Mohammad Tarin Tasnim, and I am going to submit my presentation on ultrasonic machining under the course of modern manufacturing process. So first, the content of this presentation will be introduction of ultrasonic machining, schematic diagram, principle and working, mechanism, magnetic design for MMR, that is material removal rate, process parameters and effect, ultrasonic machining system and subsystems, application, advantages and disadvantages, and finally I will show you the summary. So first is the what is ultrasonic machining? So ultrasonic machining is changing the manufacturing industry. It is superlative performance. The main reason why this process is used in the manufacturing area is because it involves less heat in the process. All the operations done with the ultrasonic machining methods are cost effective and best in result. Ultrasonic machining is an abrasive process which can create any material into hard and brittle form with the help of its vibrating tools and the indirect passage of abrasive particles towards the workpieces. It's a low material removal rate machine process. So here is my second slide, and there is shown various work samples machined by ultrasonic machining. The first picture on the left is a plastic sample that has inner groups that are machined using ultrasonic machining. The second picture is the middle. The middle is plastic sample that is complex details of the surface. And the third picture is a coin with grooving by USM. So this is the schematic diagram, and here there's some parts. There's transducer, workpiece, slurry pump, acoustic head, tool holder, force feed motions, and everything. I'm going to tell my next slides. So first, the principle of the working. The process is performed by cutting tools which oscillates at high frequency, typically 20 to 40 kilohertz in abrasive slurry. The tool is gradually fed in with the uniform force. The high speed reciprocating of tools drive the abrasive grains across a small gap against the workpiece. The impact of the abrasive is the energy principally responsible for material removal in form of small wear particles that are carried away by the abrasive slurry. The tool material being tough and ductile, wear out and much slower. So the mechanism, the basic components to the cutting action are believed in to be the direct hammering of the abrasive into the work by the tool. It's a major factor. The impact of the abrasive on the work, then cavitation, induced erosion, chemical erosion caused by slurry. So ultrasonic system, there is consists of power supply, transducer, tool holder, tools, and abrasive. In the right side, the schematic diagram has been shown. So first, the power. To start a machining process, the power is required. This is essential, as the diagram showing the first is connected to the power supply. The second one is transducer. Two types of transducers are used in ultrasonic machining to convert the supplied energy to mechanical motion. They are based on two different principles of operation. One is magnetostriction and another is piezoelectricity. So magnetostriction is when the material is placed in a sufficiently strong magnetic field, the magnetic moments of the domain rotate into the direction of the applied magnetic field and becomes parallel to it. During this process, the material expands or contracts until all domains have become parallel to one another. Very common magnetostrictive composites is the amorphous alloy, that is iron, silicon, boron, carbon, with its trade name is made glass 2605 SC. So piezoelectric transducers, this is such as quartz or lead, zirconate, titanate, generate a small electric current when compressed. Conversely, when an electric current is applied, the material increased minutely in size. When the current is removed, the material instantly returns to its original shape. The tool holder or the acoustic head, its functions is to increase the tool vibration amplitude and to match the vibrator to the acoustic load. It must be constructed of a material with the good acoustic properties and be highly resistant to fatigue cracking. So here's the picture has been shown here. The acoustic head can be different shape like tapered or conical, exponential, and stepped. The acoustic head is the most complicated part of the machine. It must provide a static force as well as the high frequency vibration. So there has been shown three figure: exponential, tapered, and stepped. Now the tools. The tools should be constructed from relatively ductile material. The harder the tool material, the faster its wear rate will be. It is important to realize that finishing or polishing operations on the tools are sometimes necessary because their surface finish will be reproduced in the workpiece. The geometry of the tool. The geometry of the tool generally corresponds to the geometry of the cut to be made. Because of the overcut, tools are slightly smaller than the desired hole or cavity. Tool and tool holder are often attached by silver bracing. So the most important thing is the abrasive. So abrasive slurry, there is common types of abrasive: boron carbide and aluminum oxide or silicon carbide. So here this water most is common in liquid, benzene, glycol, oils, and high viscosity decreases MMR. So now the applications of this ultrasonic machining is mainly used for drilling, grinding, profiling, coining, piercing of dies, welding operations on all materials which can be treated suitably by abrasives, used for machining hard and brittle metallic alloys, semiconductors, glass, ceramic, carbides, etc. Used for machining round, square, irregular shaped holes and surface impression. So the advantages of ultrasonic machining. Uh, this machining in any materials, regardless of their conductivity, uh, ultrasonic machining applied to machining semiconductors such as silicon, germanium. UCM is suitable to precise machining brittle materials. USM does not produce electric, thermal, chemical abnormal surface, can drill circular or non-circular holes in very hard material, and less stress because of its non-thermal characteristics. So the limitations of USM. USM is a low material removal rate. Tool wears fast in USM. Machining area and depth is resistance in USM. So another disadvantage is requires higher degree of integrity and skills, no certified records of radiography, unnecessary large grain size cause defects. So process parameters and their effects. The process parameters which govern the ultrasonic machining process have been identified, and the same are listed in this slide. So first is amplitude of vibration. Next one is the frequency of vibration, feed force, heat pressure, and then abrasive size, contact area of the tool, then volume of abrasive slurry, then flow strength of the tool and workpiece. So some mathematical derivations of material removal rate has been shown in this slide. So it's continuing here. The impulse force on the tool and work would be balanced, and thus the impulse on the tool can be expressed in this way. So here is the slides for the derivations. So finally, we have got the material removal rate. So the effect of parameters of material removal rate here, which is when x-axis is x and y MRR, this is top left side figure, and then is related to the area. This is the top right, then with the DG versus Q curve, then F versus MRR curve, and finally, which slurry will be has been used. If we use aluminum oxide slurry, then MRR is shown, and boron carbide is used, then MRR has been shown in the bottom figure. So the summary is here. And that's all of my presentation. Thank you very much.
Okay, thank you, Tarin, for the presentation. And any question from audience?
Sir, I have a question, sir.
Okay.
Malva, sir. Sir, I want to ask that this is ultrasonic machining, what I understand. Ultrasonic machining, from the very name, it is understood that the sound velocity should be something above, as the slide also said, 20 kilohertz. That is the frequency of sound, is the production of sound.
Yes,
the
sir.
tool head and other thing, those things, I mean, the mechanism, I couldn't understand the mechanism. I mean, how it is impacting the brittle material. I mean, sound has to be propagated. This is the generation of sound, how the sound is generated. Beyond that ultrasonic range, that is the 20 kilohertz, and above is called the ultrasonic range of sound.
Okay, sir.
Tarin, can you
Okay, sir. First, the power supply is connected with the electromechanical transducer, and that electromechanical transducer is connect in that portion. There is a magnetostrictor where the magnetostriction has been occurred, and from that area, the ultrasonic, the sound has been generated.
Is the acoustic aid is the sound generator. First, I mean, I need to be clear that the material removal is done by the ultrasound or some kind of physical contact with the workpiece and the tool holder.
No. There will not be any contact between the tool and the workpiece.
Okay, the tool holder is supposed to produce some kind of ultrasound beyond 20 kilohertz, is it?
Tool holder will not produce the sound. Is the transducer will produce the sound, and tool holder is only hold the tool, and it will not contract with the workpiece. It's just kissing position, not in touching.
I mean, then what is the job of the tool holder? Tool is said that it is, say, in a milling machine, or say that is a tool. Okay, that cuts, that gives the cut or cutting depth. So here we are going to the same operation, going to do the same operation, but some other thing, some ultrasound, not the tool itself, who will come and contact with the workpiece and cut the or remove the metal. That is what I am telling.
Sir, I understand your question. how the ultrasonic sounds or how ultrasonic frequency has been generated. Am I right, sir?
Exactly, sir. I wanted to ask that how the material is removed by the principle of ultrasound.
Yep. Okay, Tarin, can you explain that?
Okay, sir.
I think in your next slide, can you go to the next slide, principle and working?
This one.
Yep. Can you increase the size of the image on the right side?
So to my understanding, there is one thing. I may be very wrong. I may be very wrong. I'm telling. I'm afraid. But something like that. Say everything in every living being as well. Everything has an actual frequency of vibration. Now there is a you call resonance. If something goes into the resonance frequency, then say a material it will fail. If I take that material to its natural frequency of vibration. Now, is that the tool head that is producing the ultrasound in that range, something like that? So that that material fails means that material is removed, something like that. The principle, the working principle of ultrasound for removing material from a workpiece.
I don't think so. It's not like that. First, I think we should give the opportunity to Tarin to describe the principle here, and then I will clarify it.
Sir, here is the principle has been shown in the slide.
No, you just don't show the slide. You
Okay, sir.
talk.
Working principle, sir. When the tool is supplied with an electric current and high frequency will generate vibration or less amplitude, and the slurry. There is a slurry which is already passed from bottom side. So the corrosion or just like that will not happen in such a way.
Okay. I think I have to explain a little bit on
Okay,
this.
sir.
It would be nice if I could have the control. Okay. First of all, about the frequency, actually the tool vibrates. Function of the transducer is to induce that vibration in the tool. And the vibration of that tool is very low amplitude, but very high frequency, which is 20 to 40 kilohertz. And whenever there is a vibration, there is sound, what Mahabu was talking about, how sound is generated. Once you, for example, in the guitar, if you strike the wire, you don't continuously apply the force in there. Due to the vibration of the wire, the sound generates. So that's why we call it ultrasonic, and the vibration range is very high. That is why we call it like ultrasonic machining. And the machining, how the machining is done. Can you expand your slide? Can you make it full screen?
Okay, sir.
Full screen.
How material is removed. The principle of material removal is that, on the next slide, can you go to the next slide? Yes. Oh, I think that's one.
Yes,
No,
a diagram is shown in the right side.
not this one. I'm talking about the
Principle,
Principle.
the page,
working principle.
right side of the principle.
Just this
Here
one.
is a picture that
Just stay in here. I'll talk. Okay. So how material is removed? When the tool vibrates at a very high frequency with low amplitude, there is a small gap between the tool and the workpiece, and the salary stays in that gap. Just if you see the picture on the right bottom, uh, and the salary has some abrasive particles like silicon carbide or aluminum oxide. These particles, due to the vibration of the tool, they move very fast, and when they move very fast, they strike both the tool and the workpiece at a very high speed. And the wear rate of the particles are very low compared compared to the workpiece that we want to remove the material from. Due to the strike of continuous strike of these particles on the metal surface, the metal surface gets eroded, and that's how material is removed in here. Just like if you see the sanding operation to remove the to
So, I understood, sir. Can I add something, sir, with your permission?
yes, of course.
Sir, what I understood that, as you said, the sandblasting in our shipbuilding industry, we
Similar
use
kind of
air
thing.
force. I mean, the force of compressed air. And
Yes,
along with that, we send through a venturi. We send the sand with high speed,
very high speed. Yes,
metal surface, cut the or the it removes the scale of the metal.
still of the metal. Yes.
Get a fresh surface. Exactly the same thing is happening. Here the force is generated through that ultrasound, and there is the abrasive material which is producing the same effect as the sand is producing on the metal surface.
Metal surface. Yeah, exactly
This is
same.
how it is working, sir, I believe.
Only difference is you
It is
change
controlled.
you're supplying the sand continuously, but in this case abrasives are there present in there. You just vibrate the tool. That's
Exactly, sir. Vibrate the tool,
frequency.
the place where it is necessary, the
Yes.
profile. To generate the profile, first in first two slides, Mr. Tarin said, shown some particular profiles.
Yes.
So the tool will be probably traveling through those spaces where there is already abrasives. So that abrasive will create that profile by the vibration generated by the tool head.
Yes, yes, that's what. That's the working principle. Okay, any other question from audience? Okay, then I have several concerns about your presentation. The first one I have already told you is we also need to see the quality of the presentation, right? In the first lecture, I have already told you about that, like the quality of the presentation also counts. So in your slide, making your slide, first of all, you need to make the background white. Second, you don't use animation too much. Only the necessary animation can be given. And third is do not use something like these effects. It creates really it's very difficult to maintain these things, and it also takes time for preparing the presentation. So instead of giving those time, you just use the white background with the text as minimum as possible, and you talk. Okay, you just don't show your slides. You need to talk. Presentation is not about watching the slide, it's about your explanation of slide. Okay,
Yes,
so
sir.
and also when you show the material removal rate, those equations, the derivations, if you don't want to discuss the derivations, then you just skip that. You just discuss the assumptions and the parameters, and then you go to the final equation and say this is the final form of the equation, and you can explain the equation. What are the factors the material removal rate depends on? Can you go to that image where you have shown like the material removal rate for various parameters?
Graph.
The graph. Here. And in this graph, you have just there is a lot to discuss in this graph, but you did not do that. I think you have laggings in your study anyway. The thing is that we understood that that's Q is the material removal rate. What is F?
Force.
Force.
Force of
Applied force. Sorry, generated force.
generated force.
Total.
Yeah, that's what you need to explain. Like the first graph is about the material removal rate based on the force generated during the machining, and also the area of the for various areas of material removal. Okay, and the second, what is A naught? What's A naught? The
Is the
right
area, sir.
area. Okay, so how material removal rate depends on the area? It's linear. the material removal rate increases with the increase of area, and at the same time the material removal rate also increases with the, for a constant area, material removal rate also increases with the frequency f.
Force.
Is that
Frequency.
force or frequency? I think that's frequency.
This f is frequency, sir. Small f frequency.
Small f is supposed to be frequency, hertz.
And
Yes, sir. Frequency.
what is dz? Small dg on the left side, second figure. So in the case of graph, what I'm telling you is, like, in the case of graphs, you need to discuss the trends and how these are, how the material removal rates are affected. So that's like this one on the last image you have described quite a good way, but also you did not discuss what is C.
Which one, sir?
Can you tell me in the last figure, last graph, what is C? That is small c, C-axis, what is that?
Aluminum, where abrasives are used.
See.
Abrasives.
This is the
Maybe
slurry I have
carbon.
used for aluminum oxide.
Yeah, that's aluminum oxide and boron carbide, but the horizontal axis, what does it mean?
For aluminum oxide, for when we use aluminum oxide, then the graph will be the bottom curve, and if we use the boron carbide, then the graph will be the top curve.
Hang on.
Darren, what is C?
Let me ask the question. What is small c here? And what is the horizontal axis actually? What the horizontal axis represent? Like for example, in a XY curve, okay, we say that as one is y-axis and another one is x-axis. In this case, what is this x-axis? What does the x-axis mean? Like
Sir, this time
you're not sure because if you can study the if you look at the equation, can you go to the renewable rate equation?
this is the concentration of abrasive drift, sir.
Yes.
Is C.
The concentration.
The concentration
Huh?
of
Concentration.
abrasive drift, sir.
So the explanation will
Yes,
be
sir.
with the increase
Sir,
of
I'm just showing you the equation.
rate increases. Okay.
This C, sir. The concentration of abrasive drifts in the slurry.
Yep.
This
So that's how you actually describe
this one is C.
things. Okay. Anyway, I think you'll really improve in your next presentation, and I hope so. And I have some things to inform you. Before that, I will stop the recording, and then I'll start.